Learning outcomes. At the end of this chapter, you should be able to explain about device management. Describe about device driver interface. Describe about device driver API. Describe about driver kernel interface. Device driver. A device driver is a piece of software that interfaces a particular piece of hardware. Driver can be separated from operating system because of new functions can be added to the driver without requiring the operating system to modified, recompiled, and redistributed. Driver responsibilities. Initialize devices, interpreting command from OS, schedule multiple outstanding requests, manage data transfer, accept, and process interrupts. Device drivers manage the complexity and differences among specific types of devices, disk, mouse. It manages queues and buffers, special storage holds stream of bits from device, and send them to the CPU. Device controller. Device controller responsible for moving data between the peripheral device, it controls, and its local buffer storage. I/O operation. Device driver loads the register within the device controller. Device driver gives an instruction to devices to perform the operation. Device controller examines the contents of the register. For example, read request from the keyboard. Controller starts transfer data from the device to its local buffer. Data complete transfer, device controller informs device driver that it has finished its operation. DMA, controller, direct memory access. Transfer a block of data, bytes, directly to, or from its own buffer storage to memory. DMA saves CPU time by controlling data transfer between I/O device and memory. Device management. Device management is the part of the OS that manages hardware devices. It is implemented through the interaction of a device driver and interrupt routine. Device manager monitors every device, channel, and control unit. Its responsibility includes: must track the state of the device, when it is idle, when is being used and by which process. Must maintain the information in the device status table. May maintain a device descriptor to store other information about the device. Choose the most efficient way to allocate all of the system's device, printers, terminals, disk drives. Makes the allocation, starts its operation. Deallocates the device. Device management. Device management organization. Device driver interface. The designs are different from operating system to operating system. There is no universal organization. Each operating system has two major interfaces to the device manager. The driver, API. The interface between a driver and the operating system kernel. Differences between I/O devices, device driver types. Data rate. The main differences in data transfer rate. Application. Different devices have different use in the system. Complexity of control. A disk is much more complex, whereas printer requires simple control interface. Unit of transfer. Data may be transferred as a stream of bytes or characters or in larger blocks. Data representation. Different data encoding schemes are used for different devices. Error conditions. The natures of errors differ widely from one device to another. Unit of transfer. Block, fixed-sized block data transfer. Character, variable-sized data transfer. Terminal, Character driver with terminal control. Network, streams for networking. Type of device driver. Character device interfaces. Block device interfaces. Network interfaces. Device driver, API. API, Application Programming Interfaces, is an application method that can be used to access a certain function. System API provides the interface between applications and system resources through system calls, also called monitor calls, which the application execute a special operation that trigger an interrupt. Driver, API, provides a set of functions that an programmer can call to manage a device. Open, close functions to allow initiate, terminate of the device's use. Open, allocates the device and initializes the tables and the device for use. Close, releases dynamic tables entries and releases the device. Read, write functions to allow the programmer to read, write from, to the device. A consistent way to do these operations across all the devices is not possible, so a concession by dividing the devices into classes is made, such as character devices or block devices, sequential devices or randomly accessed devices. IOCTL function to allow programmers to implement device-specific functions. Driver kernel interface. Figure, device management. Device-specific code in the kernel interacts directly with the device hardware. Supports a standard and internal interface. Same kernel I/O system can interact easily with different device drivers. A collection of observations. Driver kernel interface. Kernel. The primary purpose of the kernel is to manage system resources, and provide an interface so other programs can access these resources. Hides system hardware, to present an abstract programming interface in the form of system calls and library functions. Provides abstraction and management for the following concepts: processes, resources, virtual memory, file system, inter-process communications, IPC. Provides devices drivers to manage interaction with specific devices. Written mostly in C, with a little assembly language for low-level processing. Driver kernel interface. Kernel types. Solaris. Completely modular kernel. Can load device drivers as they are needed. Discovery of a new device automatically results in search and load of corresponding module. BSD. Must be told at compilation time about devices on the system. Linux. Cross between Solaris and BSD. Must know about all hardware before resulting in one large kernel. Can be configured to load drivers only when needed. Limitations on modularity dictated by PC hardware. Summary. Do the following and present in class today. The device manager's job is to manage every system device as effectively as possible, despite the unique characteristics of each. The devices have varying speeds and degrees of shareability, some can handle direct access and some only sequential access.